Okay, good day. Today we will discuss assessment of your measured radiation. Previously, we have discussed that our measured radiation has a spread of possible values. And then from this spread of possible values, uh, we need to assess whether our measurement based on this spread of possible actual radiation is a measure of true activity or could be the absence of an activity. Okay, now for our topics of discussion, we would discuss first types 1 and 2 errors. Then we will discuss briefly your hypothesis testing. Then we will discuss the minimum significant measured activity for your radiation. And then lastly, we will discuss minimum detectable true activity. Okay, we will now discuss type 1 and type 2 errors. So basically, your type 1 error is the rejection of your null hypothesis when the null hypothesis is true. Okay, so usually we associate null hypothesis with a negative result. So for example, there is no significant difference, there is no association, null, there's no difference, no association, they're similar. And once we reject the null hypothesis, there is a difference between groups, there is association, there is link, and so on. So we usually associate the rejection of the null hypothesis to a positive result. So yung type 1 error nyo is rejecting the null hypothesis when the null hypothesis is true. So basically, your type 1 error is a false positive error. So sinabi nyo positive yung result, but when in fact, it's negative. So that's your type 1 error. Now, your type 2 error is the error associated with accepting the null hypothesis when it should be rejected. So yan, dapat in reality, it should be rejected. So dapat ang result ay positive. However, we accepted the null hypothesis, hence, we associated with a negative result. Okay, so yung ating type 2 error, we associate that with your false negative. So para mas madaling tandaan, type 1 error is your false positive, when in fact dapat negative siya, but your test show that it's positive, whereas your type 2 error is your false negative. When in fact, dapat positive yung result, pero negative yung nireport nyo or you accepted the null hypothesis. Okay. So, if you recall, I have shown you earlier yung 2x2 contingency table. So, may pangalan yun, class, yung 2x2 contingency table. So, I think you have encountered this in one of your group quizzes. Yung with disease, without disease, tapos tested positive, tested negative. So you have, if you recall, you have this table. So these are the correct predictions, and then we associate this table as your false positive table. And then this part of your table, contingency table, is your false negative part. Okay, so you have already encountered this in your 2x2 contingency table for with the disease status crossed with your diagnosis result. So yan, nakita nyo na yan. So yung false positive is your type 1 error, and your type 2 error is your false negative. Okay, for hypothesis testing, so we have your null and alternative hypothesis. So usually you have this example of your null hypothesis, yung there's no difference between groups, or yung alternative hypothesis niya, yung kabila naman, yung opposite is yung there is a difference between groups. So usually your null and alternative hypothesis, kung meron kang hypothesis universe, so you have your null hypothesis. Usually, yung alternative hypothesis is a complement, yung complement set ng lahat ng hypothesis nung yung yung null hypothesis. Complementary yung dalawa. So medyo exclusive yung dalawa. So kung hindi siya null hypothesis, alternative hypothesis siya. Kung hindi siya alternative hypothesis, null hypothesis siya. So there are other forms of the hypothesis na testing na meron tayo. So yung there's no association versus there is association, there is no link versus there is link. So most decision makers who rely on data want to reduce both type 1 and type 2 errors. So anong yung type 1 error? So yung type 1 is yung false positive. Ulitin natin kasi important ito, yung false positive. So yung false positive is yung rejecting the null, reject yung null when it should not be rejected. When it should not be rejected. Okay? So ibig sabihin, nag-alternative hypothesis yung ginawa mo, pero dapat null ka pa rin. Okay? So yan yung type 1 error ulit. Then yung type 2 error is you accept the null hypothesis when it should be rejected. When it should be rejected. So, ibig sabihin, in-accept mo yung null hypothesis, tinanggap mo siya, pero dapat alternative hypothesis yung manaig. So you basically you accept the null when it should be rejected. So that is your type 2 error. Okay, so let's now discuss a case 1 of assessing our radioactivity measurement. So suppose you have a true activity that is equal to 0. So let's say totoong 0 yung activity. Note that in our counting, we have your gross count over time of your count minus your background count over time of background count. So yung difference nung net counts nung rate nung count ng gross minus rate nung count ng ating background na radiation gives us an idea of the activity associated with the source kung nasaan nandun nakatapat yung detector. So yun. So ulitin natin. So naalala nyo lang dati. So your activity is given by gamma NG, gross count, yung total count, over yung time ng gross count minus your background count over time ng background count. So this gives you your measured activity. However, there are some uncertainties from your gross count from your background count. So these uncertainties lead to an additive type of measurement when it comes to your variance. So meron kang additive error associated with the variance of your gross count and your background count. So based on this, there's a likelihood that your machine or your instrument would give a measurement that ranges from in this range, in this type of your distribution. Okay? So pwedeng magkaroon ng biglang unstable, halimbawa yung background count natin, 'di ba? It's varying, 'di ba? Significantly across time. So kung halimbawa meron tayong background noise na hindi stable or background radiation na hindi stable, it's possible that at certain times values of your TG and TB, negative yung nami-measure natin na activity. So the range of measurements vary from your could have a value, yung measured activity nyo could have value of a negative number to a positive number. So in this case, yung value ng true activity ninyo, which is kung say hindi naman nag-exist, let's say true activity is 0, this case na meron kang A equals 0, since yung variance natin is positive and may spread ng values ng possible measured activity, ibig sabihin, yung A equals 0 na actual reality may manifest to a positive measurement in your instrument. Okay, so ano yung remedyo natin doon? So one way to uh, solve that issue is that maglagay ka ng minimum activity na pag mas malaki sa A sub 1, in this case, greater than A sub 1, ibig sabihin, yung activity mo ay totoo. Okay? Is this clear? So, I hope this is clear. So, ibig sabihin, pag greater than A1 yan, ibig sabihin, i-reject natin yung null hypothesis na A equals 0. Okay. So, we can arbitrarily set a minimum measured activity, A1. So, depende sa atin yun kung ano yung alpha natin. Pwedeng alpha equals 10%. Pwede ring alpha equals 5%. So, this is arbitrarily assigned by your by some decision maker. So, yan. So, ano yung A1 na yan? Ibig sabihin ng A1 na yan, ito yung value ng activity with the corresponding z-score. Isulat natin z sub alpha such that meron kang halimbawa, yung area nito is 1 minus alpha. So, ibig sabihin, kapag nandito yung value mo, nasa region ng 1 minus alpha, ang assessment natin, 0 yung activity. Pero kapag nandito na sa region na ito, pag lumagpas ka na sa A1, ibig sabihin, may significant radiation ka nang name-measure based on this pag-set up nung ating value na A1. Ibig sabihin, significant na kasi nasa alpha regime ka na, nandito ka na sa area na ito nasa maliit na probability ka na kapag lumagpas ka sa threshold na A1. So, ibig sabihin, meron ng activity and then we can reject the null hypothesis na A equals 0. Okay, let's now look at yung case na meron tayong true activity. So, if there is true activity greater than 0, again, may spread ulit tayo ng possible measurements. From this spread of possible measurements, meron tayong probability na yung measurement natin is below the initial threshold that we have set. Mas mababa sa A sub 1. Okay, and in this region, sinasabi natin that there is no significant activity yet based on your on the previous slide, so sa discussion natin na iyon. So dito sa case na ito, ang assessment natin is sabihin na walang activity, but in fact, merong activity. So there's some form of error here. Okay? So let's recall yung variable alpha and beta. So yung alpha dito, class, dito, yung area na ito, itong alpha na ito, ang sinasabi niyan is walang radiation, walang activity, pero sinabi natin may activity. Okay? Okay? Whereas for your beta, yung area ng beta dito, ang sinasabi natin dito, since below A1 iyan, below the threshold, ang assessment natin is, in reality, merong activity. In reality, merong activity. Pero ang assessment natin, since below siya ng initial threshold, ang sinabi natin na walang activity. Okay, so this is through the name of your alpha and beta. So alpha is associated with your type 1 error. And yung beta here is associated with your type 2 error. Okay. So meron tayong meron tayong consequence dito sa mga bagay-bagay na iyan. So kapag yung alpha natin 5%, ibig sabihin yung area dito, 5%. Pag tinaasan natin yung area na yan na alpha 10%, ano ibig sabihin diyan? Yung A1 magmo-move to the left. It will move to the left. It will be lesser. So ibig sabihin yung threshold natin mas mababa. So kung yung threshold natin mas mababa, ano yung mangyayari? Mas tataas yung likelihood na magkaroon tayo ng type 1 error. So, tataas yung likelihood na magkaroon tayo ng type 1 error. Okay? Yung beta, yung type 2 error, we are also setting it. So, ganito yan. So, once A1 has been decided, pinili na natin kung ano yung A1 based on our level of significance na alpha. I hope na visualize ninyo. So, meron tayong variance na alam natin from our measurement in our attempt to measure yung true activity, may variance tayo. So, from that, and then given your beta, we can deduce, okay, kung ano yung value ng A2. So, given yung beta and yung spread, yung variance. So, isulat natin dito, sigma true activity. So, given your beta and your sigma for your true activity, we can estimate A2. Okay? So, yan. So, ngayon yung beta, it's arbitrary. This can be arbitrarily set, and your alpha can also be arbitrarily set. Okay, ano yung consequence naman kapag yung beta mataas, if beta is higher? Okay, kapag beta is higher, mas mataas yung beta dito, we are considering a larger area of our normal curve. So, ibig sabihin, yung A2 mo, A2, lalapit pababa, mag-move to the left. Mas mag-move to the left pa kapag mas mataas yung beta. Mas mataas yung type 2 error. Okay? On the other hand, kapag naman beta is smaller, pag pinalit natin pa yung beta, kasi normal curve yan, gusto natin maliit yung beta, mas gagalaw yung, if beta is smaller, ang mangyayari is gagalaw yung curve to the right. Okay? Okay, so I hope this is clear. So depending on how you want to report the existence of radiation, may impact yung pagpili nyo ng alpha and beta. Okay, let's now proceed to the calculation of your minimum significant measured activity. So, if you recall, ito yung meron kang A equals 0 in reality, tapos maglalagay tayo ng cutoff dun sa region na kung saan ang area ay nitong right tail ng ating normal probability distribution. Ito ay alpha equals 5%. Okay? So, ulit, kapag alpha is 10%, mas mababa yung threshold natin. Okay? Pag mas mababa yung threshold para mag-declare na merong minimum significant measured activity. So, if you recall, this is our measured activity. Okay? Ito yung expectation value ng activity natin. Rate ng gross count minus rate ng background. So, ito yung error na na-introduce. Okay, so note that yung variance natin is given by this expression, sigma A squared equals detector efficiency, gamma squared, times NG over T squared G plus NB over T squared B. So, recall na pwede natin siyang gawing rate. In terms of rates, you have this expression. So, your gross rate is NG over TG, and your rate of your background is NB over TB. So, let's introduce a new variable called RNC, or your net count rate. So, I hope this is clear na yung gross rate nyo is equal to your background plus your net count. Okay, so gross rate, yung nabibilang na rate, yung actual na nabibilang na rate is equal to your background plus your net count. So, substituting this in our variance, So we now have an expression for your standard deviation. So sigma gamma square root of RB plus RNC over TG plus RB over TB. So continuing, so this is our our standard deviation. Suppose we have a measurement greater than 0 and we want at most a 95% spread from 0 to the right as the threshold for your minimum significant activity. So ibig sabihin yan, ito yung 95% natin, 95% natin na area, kasi ito is yung alpha, which is, let's say, set it to 5%. Okay, so note that yung actual activity natin is equivalent to your gamma times your measured net count or yung net rate natin, ng tg minus nb tb, which is in reality is your RNC, R ng net count. Okay, so your actual activity is alpha times RNC, yung measured activity natin. So yung probability na yung gamma RNC is greater than Z alpha sigma A is equal to 0.95. So this is that particular area. So i-convert natin siya into i-convert natin siya into Z-score. So this is kasi ang mean natin dahil we assume that yung activity natin is 0. So actually ano yan, activity minus mean activity, which we assume to be 0, is greater than yung Z-score na ito, na 95% yung buong yan, times sigma alpha A, which is your variance, so 0.95. If we look at our distribution na Z alpha, in which the area is 0.95, this can be done in your Excel. The command is norm.s inverse of 0.95. Yung area natin is yung Z alpha natin is equivalent to 1.645. So from this relationship, we have this equation. RNC is equal to 1.645 square root of RNC-TG. Take note yung RNC natin, ito yung ating yung related to sa sa count earlier. So pinagsama ko na yung may RB na term. So algebra lang iyan. So yan yung equation natin. Okay. So palitan natin yung 1.645 in general ng Z alpha. In general, palitan natin ng Z alpha. Ito yung 1.645 kanina. So we now have our value for RNC. And then we can square both sides of the equation. Note that we know the measurements for your background count rate, total time for your gross rate, and then total background count. And then we now solve for RNC by squaring both sides. So we now have R squared NC equals Z alpha squared RNC TG plus RB times 1 over TG plus 1 over TB. So this can be transformed into a quadratic equation. So ito, ang A natin equals 1. Ito yung value natin ng B, negative Z minus alpha squared over TG. And then this is the value of your C. So using your quadratic formula, we will take yung positive solution because this is the physically realizable rate. And then this is also manifested in our diagram earlier kung saan magkakaroon ng expected rate, kung saan magkaroon ng cutoff. So this is it, RNC. Okay, proceeding with the computation of RNC. Okay, so continuing. So we now have our RNC as this. Yung net rate ng net counts. Ito yung solution. So take note, alam natin yung RB, alam natin yung TG, alam natin yung TB, at alam natin yung Z alpha. Sinet natin yan. It could be further simplified by setting TG equals TB equals T. And then we would arrive at a quantity LC equals RNCT. LC equals RNCT. So yan yung ibig sabihin na count, yung total count kung saan masabi natin na merong significant measured activity. Okay, if we compute for this, multiply yung RNC by T, we would arrive at this equation. Okay, and when NB, yung background count, is very, very large, this usually happens if we let T become very, very large. Habaan natin yung time for counting of your both your background and your count. So, hahabaan mo yung time. So, pag hinabaan mo yung time na yan, NB is very large. So, yung terms natin, this would cancel out, would be essentially 0. Itong term na to would be essentially 0. So, ang magiging value natin is LC is approximately equal to Z alpha times square root of 2NB. Okay, so yan na yung magiging value for our count para masabing minimum threshold for your total count to say that there is activity. Okay, so most of the time, yung background natin, hindi stable. But kung yung background natin is very, very stable, mas maliit pa yung LC. So your LC is approximately equal to Z alpha square root of NB. So mas mababa yung ating threshold for your LC. Okay, so if you think about it, yung stable background, medyo consistent naman yun sa idea natin na kapag if we know more, because we know more about our system, if we have a stable background, mas may idea tayo dun sa system natin. So, dun sa stable background na case, mas maliit yung counts needed para sabihin natin na merong existing radiation, merong significant na measured activity. We can have a better conclusion on that if we have a stable background. Contrast to that with the value of LC kapag unstable yung background na square root of 2NB, I hope nagme-make sense sa inyo na mas mataas yung LC kapag unstable versus LC na stable. Okay, so intuitively, I hope this is clear to you, because if you have a stable background, may stable ka na radiation na background, you can make better conclusions, easier conclusions at lower cutoffs. Okay, let's look at our minimum detectable true activity. As I mentioned earlier, we set up kung anong gusto nating beta, and then from your beta and we know already yung A sub 1, and this A1 is set up from your alpha. So given your beta and your spread, knowing the spread of your true activity, okay, so magkakaroon tayo ng calculation kung ano yung value nung A2. Okay, so ito yung condition natin. Beta is equal to probability of RNC. Ito yung RNC, yung threshold natin. RNC, yung threshold natin kanina na rate ng activity, kung saan masabi natin na may significant activity. Yung RND, ito yung activity na masabi natin na meron tayong na-detect na true activity, wherein yung beta, ito yung sinet natin initially after knowing what is alpha and what is A1. Okay, so yung RND, hindi natin alam. May alam tayo sa spread ng sigma ND, which is also a function of RND. Okay, and then based on this, we also know Z beta because we assigned this. So knowing RNC and sigma ND, na kay Turner yung derivation, and in the similar manner as the derivation for your for your LC. So gagawin lang natin yung run through. This is from Turner. So your RND is equal to RNZ plus Z beta square root of your variance. Okay, and then same when TG equals TB, we have this assumption that LD, yung detected, yung may detectable counts, is approximately equal to LC times Z beta square root of 2NB times yung square root ng buong terms na ito. And then again, at very large NB, malaki-laking value ng NB approaches to infinity, or a very large value, mag-vanish tong values na to, mag-vanish din itong value na to, mag-vanish din itong value na to, ang matitira na lang is yung 1. So you will have your detect LD be approximately Z alpha plus Z beta square root of 2NB. And then if we set that alpha is equal to beta, and then we can say that LD is approximately equal to 2LC. So I hope this is clear. So yan, kapag equal yung alpha at beta nyo. So that is your minimum detectable true activity. So in essence, class, kapag gusto mo masabi na totoong merong radiation na nag-e-exist, I think para certain ka, it should be greater than LD. So it's pag tinignan niyo yung graph natin, 'di ba? Yung graph natin kanina from your previous slide. Okay? So meron kang dalawang peak. So you have LC here. Okay? And then you have your LD somewhere here to the right of your LC, and then your associated rate is RNC. Dito is RND. So, madali ang buhay kapag yung ma-measure mo na radiation ay greater than LD. If it's greater than LD or greater than RND, sure ka na merong radiation. Okay? Sasabihin mo, yes, there is true activity. Kapag less than LC, dito, okay, pag nandito sa side na ito, less than LC, yung measure radiation natin, ang masasabi mo is masasabi mo is walang activity. So, or no significant activity. Madaling sabihin yung case na there's no significant activity. Yung case between LC and LD, ito, yan, gray area yan. So, may gray area kapag yung na-measure mo na value is between LC and LD. Okay? So, siguro, kapag nag-investigate ka lang, mabilis ang measurement, perhaps okay na sa iyo yung LC kung mag-investigate ka pa dyan later. Kasi mababa yung background count mo. So, mabilis ang measurements lang. So, pag greater than LC, merong significant activity siguro dito sa area na to. Pwede mong sabihin yon. Pero kapag matagal mo siyang mineasure, tas paulit-ulit, tas matagal yung counting sa background, medyo mas stringent yung ating standard. So siguro LD yung gagamitin mo na quantity. So you want for you to say that there is true radiation there, mas mataas na standard, which is yung LD. Ang disadvantage lang naman kapag mas mataas yung threshold natin is it's possible to report na sabihin nyo na wala nag-e-exist na radiation kasi mas mataas yung threshold. Kasi mas mataas yung threshold na LD, sabihin nyo na since hindi nag-e-exist yung radiation dahil mas mataas yung threshold, public health-wise, possible na may issue doon. Kasi it's possible na merong activity na nangyayari at may impact yun sa mga tao na nandun sa surroundings. Tapos sinabi mo na, ay, wala kasi ang ginamit mong threshold ay L sub D. So, there is some nuance in what cutoff yung gagamitin mo, kung LC or LD, in saying that there is no radiation or there is radiation, there is no significant activity, there is significant activity, or there is no detectable true activity, or whether there is true detectable activity. So yung language dyan, yung language ng significant activity, significantly measured activity, detectable true activity, nagmamatter yung language doon. So to summarize, uncertainty on measurements resulted in issues of assessment of measured activity. So yung may problem tayo doon sa measured activity. Tapos yung quantities alpha and beta can be adjusted to arrive at different quantities of LC and LD. So depende sa inyo kung anong gusto niyo alpha and beta. Pero as a student, I want you to examine why someone would, let's say for example, want an alpha of 0.05 versus 0.1. Bakit mas pipiliin nila, let's say, yung 0.05, or bakit mas ideal piliin yung 0.1? With respect to beta, bakit mas ideal sa kanilang piliin, let's say, yung 0.05 versus 0.1? Or, kung meron na kayong napiling na alpha, bakit yung pipiliin yung alpha equal sa beta? Bakit yung pipiliin yung alpha is less than beta? Or bakit yung pipiliin yung alpha is greater than beta? So, what do you think are the reasons kung bakit ang isang institution pipiliin yung pag-adjust ng mga values na ganyan? So, I will ask you to submit an essay or on a number of questions on the reasoning behind choosing levels of significance ng alpha natin and beta. So, thank you very much. So, this is yung lecture natin on the assessment of assessing radiation.